Hello and welcome to today's class. Let's look at machine in physics. So let's discuss machine in physics. What is machine? I'll define machine for you. After machine definition, we'll look at some basic terminology or perhaps basic term you need to be familiar with in the study of machine. And then after that, we'll now look at some important thing to note during the study of machine, and then finally we'll now solve past question for JAM and WAEC for the last 10 years for machine. Let's start by defining machine, please. What a machine by definition? A machine is a device or tool which allows a force in bracket effort, which allows a force in bracket effort applied at one point to overcome a resisting force in brackets load at another point. So I'm saying that a machine is a device or tool which allows a force in bracket effort applied at one point to overcome a resisting force in bracket load at another point. That machine by definition. In the concept of machine, what I give now, there are two words there. We have effort and we have load. Bear in mind that effort and load are both measured in Newton. So effort is a kind of load on its own, measured in Newton, and we have load too, also measured in what there in Newton. So that's by the way. So that's your definition for machine. Now let's now look at some basic terminology, please. Let's look at basic terms, basic terminology in the study of machine. What are these terms we need to be familiar with when discussing about machine? So let's look at this term, please. Number one there, the basic term, number one there is called mechanical advantage. Number one, mechanical advantage. All right. The first term is called mechanical advantage. Let's discuss mechanical advantage. All right. Definition. This is also called force ratio. It is the ratio of the load overcome by a machine to the effort applied in overcoming the load. That's how you define mechanical advantage. Please, from the definition I gave you now for this man, we said mechanical advantage can also be called force ratio. So in exam, if you have to calculate for mechanical advantage or you have to calculate for force ratio, please, the two names are the same thing. So bear in mind that force ratio signifies mechanical advantage. That's the concept. Now we said mechanical advantage is simply is also called force ratio. Why force ratio? Because hold on, bear in mind that mechanical advantage is abbreviated by as MA. MA is the symbol for representing mechanical advantage. So mathematically, I will show you why we call this man force ratio. Let's look at the mathematical expression for mechanical advantage. So MA, mathematically, I'm saying that mechanical advantage MA is equal to, I said, the ratio of the load to what? To the effort. That's load all over effort. This becomes the formula for calculating mechanical advantage, load over effort. Why is this man called force ratio? It's easy. I just told you that effort is a kind of force measured in what? In Newton. Load also is a kind of force Measured in what? In Newton. So I'm having Newton. So there are more of two forces. So this becomes what? A ratio of what? Two forces. That's why this man is called a force ratio. Please note that mechanical advantage has no SI unit, please. Note that mechanical advantage has no SI unit. Please, is this true? Of course, yes. Load is measured in Newton, effort in Newton. This will cancel this, so no unit. So I'm saying that mechanical advantage has no SI unit. So this is my first terminology I have to be familiar with in the study of machine. Please, before I move to the second one, there are two things to note before I move to the second terminology. So please note the following, please. Note number one, please note this, please. Note number one, please. Two things to note quickly. Note number one, please. Note number one. The mechanical advantage of a machine is influenced by friction in the part of that machine. Please. Note number one, please. I said the mechanical advantage of a machine is influenced by friction in the parts of that machine. That's note number one. Note number two. Note number two. Please note this, please. Number two. Note number two, please. A machine that has no friction is called an ideal machine. Ideal machine. This ideal, please. A machine that has no friction is called an ideal machine. Ideal machine. Please, you might ask me, you might be asking that, you might be, okay, you might be viewing this second note as something that doesn't make sense. What do I mean? I said a machine that has no friction is called an ideal machine. In real life sense, there can never be a machine without friction. Please, this man here is hypothetical. It's not practical. It's theoretical aspect. So this man was brought up for calculation's sake. Doesn't mean that a machine is a machine that has no friction. All machines have friction. So in this case now, I'm just taking an assumption that a machine that has no friction is what? An ideal machine. This man is not practical. Is a what? A theoretical concept, please. All right. So that's number one. Number two, please. Note number one, number two. All right. Let's look at the second term, please. Involved in the study of machine. Second term, please. Number two. Number two. Velocity ratio. Velocity ratio. All right, please, in brackets, VR. Please, velocity ratio is abbreviated as what? VR. Please note that VR signifies velocity ratio. Definition. Velocity ratio is the ratio of the distance moved by effort to the distance moved by load. It's easy. Velocity ratio can be defined as the distance moved by effort to distance moved by load. That's how you define velocity ratio. Mathematically, I'm saying that VR, velocity ratio, is equal to, said, distance moved by effort. So I'm saying distance moved by effort to distance moved by load. So distance moved by load. All right, this becomes your formula for VR. VR means velocity ratio, and the formula is given as distance moved by effort all over distance moved by load. As easy as this, please. Now listen, here is what you need to note. The difference between mechanical advantage and velocity ratio is that for mechanical advantage here, load comes first before effort. For this one, effort comes first before what there? Before load. Please note that difference. Mechanical advantage has what there? Has load first before effort, while VR, which signifies velocity ratio, has effort first before load. This is like the concept behind the second term in the study of machine called velocity ratio. Let's look at some two things to note under this again. Mechanical advantage, I gave you two things to note. Similarly, for this one here, let's look at the two important key concepts to note, please. Note number one, please. Under this, note number one, please. Are we good? Note number one, please. The velocity ratio of a machine is independent of friction. The velocity ratio of a machine is independent of friction, but dependent on the machine geometry. Machine geometry in brackets or construct the machine geometry, or in brackets construct. All right, so that's your first to note. Note that the velocity ratio of a machine is independent of friction, but dependent on the machine geometry, or you call it construct. That's your first to note. Note number two under this. Please. For an ideal machine, number two, for an ideal machine, mechanical advantage is equal to velocity ratio. Please note that for an ideal machine, under velocity ratio, please, for an ideal machine, mechanical advantage is equal to velocity ratio. That is MA is equal to VR. Please, very important. This concept is under velocity ratio. If in the question you are asked to find probably you are asked to find velocity ratio, and I give mechanical advantage as 5, we expect that VR will become 5 in one condition. What's the condition? The condition is that the machine must be an ideal machine. So I'm saying that for an ideal machine, mechanical advantage is equal to what the velocity ratio. That's how this man works. So this is second terminology in the study of machine. Let's look at the third term, please. The third terminology called efficiency. Efficiency in capital E, please. Efficiency, please. Let's discuss efficiency as the third term in the study of machine. Efficiency, please. This is the ratio of the mechanical advantage. This is the ratio of mechanical advantage to its velocity ratio. as expressed as a percentage. This is the ratio of the mechanical advantage of the machine to its velocity ratio expressed as a percentage. So what do I mean? Mathematically, yeah? Mathematically, yeah, E signifies, capital E signifies efficiency. And within efficiency, by mathematical approach, is simply the ratio of what? Mechanical advantage, that's MA over what the VR. VR signifies what the velocity ratio. This becomes your formula for calculating efficiency, that's MA over what the over VR. Please bear in mind MA over VR. MA signifies mechanical advantage, so MA there means mechanical advantage, right? Then all over what the velocity ratio, velocity ratio is. All right, so I have this guy here. Please note that I said mechanical advantage has no SI unit. Similarly, velocity ratio too has what? Has no SI unit. Why? It's easy. Distance moved by effort is in meters. Distance moved by load in meters. Meter will cancel meter, of course. From here, meter will cancel meter. This is in meters. This one is in meters. So cancel each other because distance in meter, distance in meter. So note that velocity ratio 2 has no SI unit, please. So in this case now, it means the efficiency automatically has what? No SI unit. Why? MA itself from there has no unit. We have itself from there has no unit. So it means that mechanical efficiency now will have no SI unit, please. Please don't hold on, please. We said efficiency is the ratio of mechanical advantage to its velocity ratio expressed as a what there? As a percentage. So don't forget, please, times 100%, please. All right, this becomes your formula for calculating efficiency. All right, please also note that efficiency can also be expressed in terms of work output and work input. What do I mean? In other form, I can express efficiency E as being equal to work output over work input times 100%. In case in a question whereby they didn't give you VR, they didn't give you MA, you have to find efficiency. What they gave you was just work output, work input. To find efficiency, you don't need to start using this man. Use what they use this one. That's the concept is. All right, at this point here, also bear in mind that if you are asked to apply for work done, sorry, work output, please. Work output. Please know that what work output is equal to effort. Okay, that's load. You see, load times distance moved by load The formula for calculating work output is what? Load times distance moved by load. Also, for calculating work input is given as the product of what? Effort times distance moved by effort. So it becomes the basic what's it called? The basic stuff you have to note, formulas when it comes to efficiency. So note that efficiency is what? MA over VR. It has no unit, please. Also know that Efficiency can be expressed as work output over what there, work input times 100%. Also know that work output can be expressed as the product of what? Load and distance moved by load. Also know that work input can be got by multiplying effort times distance moved by effort. And one last formula to note before we go. One last formula to note. One last formula to note, please. One last thing to note, please, before we proceed. So the last formula to note there. One last formula to note. Also note that, please, note under efficiency, please, note this, please. Note that work input is equal to work output right, plus work done against friction. Work done against friction. So work input has different formula. You can use work input as effort times distance moved by effort, or you express work input as work output plus work done against friction. These are like the basic stuff you have to note when it comes to the study of machine. With these 3 points here, let's solve past questions for the last 10 years in the study of machine. So let's solve example 1. All right.